In this video, I want to talk about data diodes. If you work in a high security OT environment, nuclear, defense related manufacturing, bulk electric, certain water and chemical facilities, you may have already heard of this term. A data diode is a hardware solution to a specific problem. How do you allow data to flow out of an OT network while making it physically impossible for anything to flow back in? A data diode is a hardware device that allows data to travel only in one direction. The reverse path doesn't exist at the physical level. It's not a software rule that blocks return traffic. It's a hardware architecture where a signal physically cannot propagate backward through the device. The name comes from the electrical component. A diode passes electrical current in one direction only. The reverse direction has no conduction path. A network data diode applies the same principle to network communication. These devices are also called unidirectional security gateways or unidirectional network appliances. Major vendors in this space include Waterfall Security Solutions, which makes the unidirectional security gateway, and Fox IT, among others. The underlying hardware principle is consistent across vendors. There is a transmit-only side and a receive-only side, with no physical mechanism for the receive side to communicate back through the device. How is this different from a firewall? Well, a firewall enforces rules in software. A well-configured firewall blocks traffic effectively, but the rules are software. They can be misconfigured. They can be exploited through vulnerabilities in the firewall OS, and they can be changed by someone with administrative access. A data diode is a hardware constraint. No configuration change makes it pass traffic in the blocked direction. No software vulnerability creates a return path. No administrative override enables bidirectional communication. The hardware doesn't have the physical components to allow a return path. For environments where the consequence of any return path is unacceptable, even a transient misconfiguration or a software bug, that distinction matters enormously. A firewall says, I have rules that should block the return path. A data diode says there is no return path. Again, think of it like a difference between a one-way valve on a pipeline and a manually operated valve set to the one-way position. The one-way valve mechanically cannot flow in the wrong direction. The manually operated valve needs someone to have configured it correctly, and it can be changed. Data diodes appear at the boundary between OT and enterprise IT in environments where the risk of any return path is too high to accept. The typical data flow is OT systems send operational data outward through the data diode to enterprise or cloud systems, but no data, command, or query can come back through. A historian sending operational data to enterprise analytics systems is the most common use case. The historian pushes data through the data diode, enterprise systems receive it. There's no mechanism by which enterprise systems can query the historian directly or send anything back into the OT environment. Utility SCADA systems sending data to control centers, regulatory reporting systems, and grid management platforms use data diodes where requirements demand that no path into the utility's OT environment can exist from the receiving end. Regulatory requirements in some sectors specify or strongly recommend data diodes. NERC CIP, the North American Electric Reliability Corporation Critical Infrastructure Protection Standard, applies to bulk electronic system operators and includes requirements around electronic security perimeters. Data diodes are a recognized control for meeting these requirements in high-risk zones. If your facility operates under NERC CIP, nuclear NRC requirements, or similar sector-specific regulations, you can check whether data diodes are specified or expected for specific certain zone boundaries. So data diodes provide the strongest possible enforcement of one-way data flow, but they come with some operational trade-offs. Because the return path doesn't exist, protocols that rely on acknowledgement, which is most TCP-based protocols, don't work directly through a data diode. You can't use a standard Modbus TCP, standard historian replication, or standard file transfer protocols through a data diode because all of these require the receiver to send acknowledgments back to the sender. Data diode vendors solve this by providing proxy software on both sides of the device that handles the acknowledgement locally, allowing the application to believe it's in a normal two-way session while the hardware enforces one-way flow. This proxy software is vendor specific and adds complexity. It must be compatible with the OT protocols and applications on both sides. Implementing a data diode requires testing to confirm that the proxied protocol behavior matches the application's expectations. The cost is also higher than a comparable firewall. Enterprise-grade data diodes from reputable vendors cost significantly more than firewalls of equivalent throughput. For facilities where the risk profile justifies that cost and where regulatory requirements mandate it, data diodes are the right tool. For facilities where a well-configured firewall with appropriate monitoring is sufficient, the complexity and the cost of data diodes may not be warranted. In the next video, we'll look at the most common ways segmentation fails in practice, how a well-designed architecture on paper gets undermined by real-world conditions and device configurations.